ఇక్కడి నుంచి స్టార్ట్ చేయండి. ఇక్కడి నుంచి ఉంటుందా? ఇక్కడ నుంచి ఇక్కడ దాకానా? ఇంకా దాకా రావచ్చా? ఎందుకంటే ఇంకా పెద్ద ఈక్వేషన్స్ వస్తాయి. ఆ క్లాంప్ దాకా కూడా రావచ్చా? ఓకే. నెక్స్ట్, ఇన్ every redox reaction, how to identify which will undergo oxidation, which will undergo reduction, which will act as the oxidizing agent, which will act as the reducing agent. So first, when a reactant is given, identify the oxidation state of the central atom. For example, KMnO4. Similarly, K2Cr2O7. Similarly, N2O5. Similarly, SO3. Here in all these molecules, first identify the oxidation state of the central atom. Here for manganese +7, for chromium +6, for nitrogen +5, for sulfur +6. Similarly, XeO4. Here oxidation state is +8. In any molecule, if the central atom exhibits the highest possible oxidation state, then that entire molecule will always act as the electron gainer or electron oxidizing agent. It will always act as the oxidizing agent. It will always act as the oxidizing agent, oxidizing. Therefore, based on the oxidation state of the central atom, if that oxidation state happens to be highest possible value, then that can be called as the oxidizing agent. Therefore, all the molecules in which central atom exhibits highest possible oxidation state will always act as the oxidizing agent. Next, second case. Observe the another set of molecules. Here ammonia. The oxidation state of nitrogen is -3. Similarly, H2S. The oxidation state of the sulfur here is -2. Similarly, HCl. The oxidation state of the chlorine is -1. Similarly, methane. The oxidation state of the carbon is -4. So when we have a set of molecules, first identify the oxidation state of the central atom. If that oxidation state happens to be least possible value, then those molecules will always act as the electron suppliers or reducing agents. These molecules, they will always act as the reducing agents. Next, a third set of molecules. So for example, observe the hydrogen peroxide. Here oxidation state of oxygen is -1. Similarly, observe the oxidation state of the sulfur in SO2. Here oxidation state is +4. Similarly, observe the oxidation state of the nitrogen. Here +4. That means in any molecule, if the oxidation state of the central atom is neither equal to highest value nor equal to least value, then that molecule will always act as both oxidizing as well as reducing. Here the oxidation state of oxygen is -1. For oxygen, the least possible value should be -2. Highest possible value should be +6 because it belongs to the oxygen family, 16th group. Therefore, its value must be highest. But here the oxidation state of the oxygen is neither equal to lowest value nor equal to highest value. Hence, it can act as the both oxidizing and reducing agent. Similarly, sulfur. For sulfur, least possible value should be -2. Highest possible value should be +6. But in SO2, the sulfur is exhibiting +4, which is neither equal to highest nor equal to lowest. Therefore, it can act as the both oxidizing and reducing. Similarly, in NO2 also, least possible value -3, highest possible value is +5. Therefore, here nitrogen can act as both oxidizing and reducing agent. So therefore, just by observing the oxidation state of the central atom in any molecule, very easily we can identify which can act as the oxidizing agent, which can act as the reducing agent, which can act as both oxidizing and reducing agent.